All right, so we're going to look at key features of square root functions. All right, so it says, is y equals x squared a function? So to figure out if it is or isn't, we first need to kind of build the table to kind of look at that. So I'm going to take the -3 and I'm going to plug it into x. So I have y equals -3 being squared, that gives me 9. I do the same thing for the -2 and so on. So if I keep doing it for the rest of the table, this would be my table for my y equals x squared graph, which is a parabola. So I'm going to graph that real quick. And so I have my parabola. So here we have a parabola. And is it a function? So remember, a function is if each x has its own unique y, which essentially means you're looking at x's and you're seeing if any of them repeat themselves. So here we have -3, -2, -1, 0, 1, 2, 3. None of the x's repeat themselves, so this is guaranteed to be a function no matter what. You can also tell if something is a function by doing the vertical line test. It's where you draw a vertical line through the graph, and if you hit it one time, it's considered a function, and it has to work everywhere. So if I keep drawing vertical lines, every time I do it, if I always hit the graph one time when I draw that vertical line, it's going to be a function. So you might ask, well, what does a not a function look like? What does that look like? Well, let's say I make a graph that looks, say, a circle. Okay, so if I make a circle the best I can, it's not the prettiest circle, and let's say I do a vertical line test going straight through here. Now I hit the graph 2 times, which means this is not a function. And if I looked at, say, some of its table of values here, like at 0, I have a y value of +8. And also at 0, I have a y value of -8. So this is an example where the x's repeated themselves and they gave us different y values. And so if the x ever repeats and you get different y values, it's not a function and it fails the vertical line test. When you draw a vertical line, it's going to hit it in 2 locations. That's not a function. All right, so we have this parabola, and up here in red, it's talking about an inverse function. So an inverse function is a reflection across the line y equals x. So remember, reflection is just kind of flipping the graph, but instead of flipping it from being above to below, instead we're flipping it over a particular line called y equals x. So if we were to write that out in more of a traditional sense, it would be 1 over 1 x plus 0. This is the equation y equals mx plus b. But they took away the 0 because if it's 0, you don't really need to write the number 0. And if you don't see a 1 in front of a variable, it's understood that there's a 1 there. So this is really just a really shorthand version of y equals mx plus b when your y-intercept is at 0 and your slope is 1 over 1. That's why it's written as just y equals x. So I'm going to graph that equation, y equals 1 over 1 x plus 0. So I'm starting at right here at 0. I'm going to count up 1, right 1, because I'm counting the slope that I have here. Up 1, right 1, and I just keep doing that. And I create this line that I'm going to reflect over. Okay, so I have this line. This is my line of reflection. And I'm going to essentially flip my parabola over this line. And when I do that, the graph's going to look like this. Now, don't worry about trying to replicate what I am doing here. This is simply to help you understand the types of graphs we're going to be looking at in this chapter. All right, so here is now I have like a sideways parabola. So the first question is the inverse graph a function? So if I go ahead and I draw my parabola, the question is this going to be a function? Well, I can do my vertical line test. If I draw a vertical line, I hit the graph located here and located here, which means its coordinates are 9, comma 3, and 9, comma -3. So the same x has two different y values. So no, this is not a function. The inverse is not a function. Well, the next question is asking us, hey, why don't we go ahead and write the equation for the inverse of y equals x squared. So they want us to basically write the equation for this red parabola that I have written. Okay, no problem. So what we do is we are going to rewrite this equation as the inverse. Well, up here, the definition of an inverse says a reflection across the line y equals x. That means the y is x and the x is y, which means if they are the same thing, it doesn't matter which one I write as x and which one I write as y. So I can switch their positions. So I can make it be x equals y squared. And that's okay because the y is the x and the x is the y that we see up here. Well, if I want to get y by itself to write an equation like you normally would, where it's usually a y equals, I'm going to get rid of the square here by square rooting. What I do to one side of my equation, I need to do to the other. So when that happens, the square and the square root will cancel each other out because they're opposites of each other. So I'm going to be left with y equals square root x. Now, don't forget, if you square root both sides of an equation, you have a plus and minus sign. And this equation represents this sideways red parabola that we see here. But let's take a look a little closer, because you can see we have a square root, but sadly, our square root graph is not a function. And Algebra 2 is all about learning about functions. So we can actually make this become a function by looking at just a section of it. So you notice we have the plus and minus sign here in our equation. But what if I just look at y equals plus the square root of x? Well, that means that I'm not even looking at the bottom part of the graph. I'm only looking at the top part. And if I do the vertical line test now, every time I draw a vertical line, I hit it one time, and therefore, it's a function. Well, what if I have only a negative in front? What if I have y equals negative square root of x? Well, that means I'm just looking at the bottom of the graph. So I'm not looking at this top part, which means if I do the vertical line test, oops, I'm going to tap a pen. There we go. If I do the vertical line test, I only hit it one time, which means this is a function. So we are going to be looking at square root functions where sometimes they're positive in the front and sometimes they're negative in front, and they just make these like little arcs heading towards the right side. So you'll see what I mean in the next slide. Okay, so it says, given the function y equals the square root of x, find the following. So here you can kind of see, we only see half of that sideways parabola, and that's because up here our equation is just y equals plus x, the positive side, the top side. And they want us to find some of our key features. So the first thing is key point. Key point is the starting point of the graph. That is right here. So in this particular problem, it's 0, 0. Then it wants to know the domain. Now remember, the domain are the x values that create the graph. So since the graph starts at 0, it's using 1, it's using 2, it's using 3, it's using 4, it's using 12, it's using 13, and it's going to the right forever. It's using all the numbers from 0 all the way to infinity. So our domain is from 0, using a bracket because 0 is one of the numbers that makes the graph, going to infinity, and we use our parentheses because you can't actually get to infinity. All right. Next thing is the range. The range is talking about the y values that create the graph. Well, once again, the graph starts right here at 0. So 0 is one of the numbers in the range. 1 is one of the numbers in the range. 2 is one of the numbers in the range. 3 is one of the numbers in the range. 4, because this graph goes on forever, it keeps going this way. So 4 would be included, 5, 6, 7, 8, all the way to infinity. So the smallest y value we have for the graph is 0, and it goes all the way to positive infinity. All right, end behavior. End behavior is going to feel a little different this time. We're still going to use the same notation we've done throughout the entire year. We're first going to talk about the left side. Okay, so we're talking about the left, that's this side over here. So as we head, as x goes to, as we go towards the left side, our x value we head towards is 0. It doesn't go into infinity because the graph stops at 0, so I can't go past that. And then that means the y value, if we follow our graph, our y value, let me put this in red so you can see it, the y value is also heading towards 0 because the graph stops right here. So that's the end behavior for the left side. The right side, let's talk about right side. Where will I put that? Okay, we'll do right side. We're talking about this side. So x is heading towards, once again, this little arrow tells us this graph is going on forever to the right. It's heading towards infinity. And therefore its y value, since this graph is up on the top side of the x-axis, it's heading upwards, you can see it heading upwards, is going to infinity. Now the relative min is the lowest is going to be the lowest point on the graph, and our lowest point is right here at 0, 0. Right. It says given the function negative square root of x plus 2. I apologize, the equation has a typo in it. That's not plus 2. It's plus 3. All right, so for this round, they want to know the key point. The key point is right there at 0, 3. It's our starting point. It's where the graph starts with. Our domain, once again, since the graph starts here, we're starting at 0. We're using 1. We're using 2. We're using 3. 4, 5. The graph keeps going forever to the right. So we are starting at 0 with a bracket and going to infinity. Now we're talking range, so we care about the y values. So this time, our graph starts here at 3, then it uses the 2, and then the 1, and then the 0, and then the negative 1. And since this graph keeps heading downwards, it's going to use negative 2, negative 3, negative 4, negative 5, all the way to negative infinity. So once again, we like to write our range as smallest number first, biggest number last. So since our smallest is negative infinity and our biggest is this positive 3, our range would look like this. All right, and talking about our end behavior. So if we're talking about the left side of the graph, all right, so if we talk about the left side, as x approaches, once again, it's going this way, it stops here. It doesn't go past this particular section, so it's stopping at 0. So as left heads to 0, its y value is going, I'll put this in green, this y value is going up here, and it stops right there at the number 3. And so as x goes to 0, the y will go to 3. And it stops because there's nothing else past that number. Now if we look at the right side, as x approaches, once again, this graph is going this way forever. So as it approaches infinity, the y value, you can see how it's heading downwards, is going to head towards negative infinity. Okay, the relative max, so the highest point of the graph is right up here at 0, 3. There's our relative max. Okay, another one. So here we have ourselves the function y equals the square root of x minus 2 and then plus 3. So our key point is located right here at 2, 3. Our domain, so the first x value that makes the graph is a 2, and then a 3, and then a 4, and then a 5, and so on and so on. So it's starting at the number 2 this time, and it's heading towards positive infinity. Okay. And now if we talk about the range, the smallest y value we have here is the 3, the 4, the 5, the 6, and as this graph goes upwards, it's going to use the 7 and the 8 and so on and so on. So our smallest y value is 3, and the largest y value is positive infinity. So once again, our end behavior, if we look on the left side, as x approaches, once again, the graph stops here. So as x approaches the number 2 where the graph stops, the y value approaches 3. Okay? And then the right side. So now we're looking over here. So as x heads towards positive infinity, the y value is heading upwards. So that's going to be positive infinity. Okay, increasing, decreasing intervals. So with these kind of graphs, oftentimes there is only one. Sometimes there's only an increasing interval, sometimes there's only a decreasing interval. There is not both. So one of these we're going to put the word none. So what we care about is, are we increasing or decreasing? And we do that by looking from left to right. So the graph starts here, and this is my left side. I'm going to head towards my right. So I am currently at 3. So I move to the next point. Now I'm at 4. I move to the next point. Now I'm at 5. I'm increasing. I started at 3. Now I'm at 4. Now I'm at 5. So I have an increasing interval starting at 3 and heading to infinity, because it's going to keep going. We're going to use the 6 and so on. That means we do not have a decreasing interval. Once again, we do this reading from left to right. All right, let's take a look at one of these. We have y equals negative square root x plus 4 plus 1. So you can see the negative, how the graph is upside down. So our key point, once again, is the starting point. So negative 4, 1. It's asking what's the y-intercept. So that's where it touches the y-axis. We have the point 0, negative 1. It wants to know the domain. So once again, those are the x values that create the graph. So we have ourselves negative 4, negative 3, negative 2, negative 1, 0, 1, going on forever. So our domain starts at negative 4 and goes all the way to infinity. Our range are the y values that make the graph. So that means over here we have the number 1 that makes the graph, the 0, negative 1, negative 2, negative 3, because this graph is heading downwards. So we're using, and it's going down forever, so it's going to use negative 4, negative 5, negative 6. It's using all the negative numbers. So our range, our smallest y value, is going to be negative infinity, and the highest y value is this number 1, because the graph stops up here. Okay, we're going to have ourselves the end behavior. So we're talking left side. So we're talking over here. So as x approaches, so as we head this way, once again, the graph stops here. So it's stopping at 4, so at negative 4. So as x approaches negative 4, the y value, once again, you look up, the point stopped here, its y value is 1. So therefore, the y value goes to 1. The right, as x, we're talking right side, as x approaches infinity, because this arrow over here on the graph is telling us going to the right forever. So as x approaches infinity, the graph is pointing down. That means the y value is heading towards negative infinity. Okay, we're talking about increasing and decreasing intervals. So once again, we're looking at reading it from left to right. So if my graph starts here, I'm starting at 1. The next point on the graph is right here, and now I'm at 0. The next point is right here at -1, and the next point right here is at -2. So I started at 1, then 0, -1, -2. That's decreasing. So this would be none, and decreasing would be from -infinity to 1. Okay, so our next one, all this stuff is kind of the same as last time, except now we're going to be talking about positive and negative intervals. So we got a key point at +3, -2. Our y-intercept, we don't have one, so none. It doesn't touch the y-axis anywhere. Our domain, once again, is starting at 3, and it's using 4, 5, and so on. So we're going to say from 3 to infinity. Our range is from our lowest y value is at -2, then we have -1, then we have 0, 1, and so on. So our range is going to be from -2 to infinity. We've talked about end behavior a few times. I'm just going to skip that one. Let's talk about the new stuff. So positive interval. Positive interval is where the graph is above the x-axis. So anything up here is considered the positive interval, and anything down here is the negative interval. So if we're talking about positive, it starts right here and all the way this way. So all that part is the positive interval, which means it starts at 7 and goes to infinity. Now you notice I put a parentheses on the 7, and that's because the 7 is neutral. It's on the x-axis. Positive interval is everything above the x-axis. Okay, the negative interval is starting here, and it goes to here. So from here to here is the negative interval. That's everything below the x-axis. So it starts at 3 and ends at 7. Oops. Which is going to have once again, a parentheses because our 7 right here is on the x-axis. It's a neutral number. It's not part of the positive. It's not part of the negative. So it gets the parentheses because it's not included. All right, our last problem, if you've made it this far, I'm going to skip these tops and just talk about positive and negative again, since this is kind of the new part. All right, so once again, the positive interval is everything above the x-axis. Once again, this is the positive part, and our negative interval is everything below the x-axis. So the section of the graph that's above the x-axis is from here all the way to 3, because 3 is where it hits the x-axis. So everything above, so this entire section here, is the positive interval. So it starts at -1, and it ends at 3. Once again, since the 3 is on the x-axis, it gets the parentheses because it's neutral. Negative interval, it starts at the 3 and goes this way forever. So it's everything from 3 to infinity. Now, I'm describing this in terms of x's. That's why I'm saying infinity, because it's going to the right forever. Because I'm describing it in terms of x's.